So what we're going to do today is something called matrix solutions for linear systems. So in other words, we're going to be solving for a system of equations when it comes to it. Okay. Now, when it comes to this type of method, right, it's going to be a little different because we're going to be learning how a computer actually solves for a system of equations. Okay. And that's a little different than we've done in algebra. There's a reason why math is called a universal language, is because it literally is, right? Any computer in the world doesn't have an actual language. It has a computer language, which is just pure math. So if you speak Russian, Japanese, or Chinese, or English, it really doesn't matter, because once you go to computer, it does the same format. So that's why everywhere in the world, the computer language is all the same, which is pretty cool, right? So that's why math is kind of a universal language. Okay. So next couple of sections, we're going to figure out how a computer actually generates this kind of stuff and input it to computer, which is pretty crazy as well. Okay. So how we're going to do this is we're going to call something a Gauss-Jordan method. So the Gauss-Jordan method is a way to solve for a system of equations using matrices. In other words, linear programming. Okay. That's a fancy word because then he invented it, but most people know it as the row reduction method itself. Okay. A row reduced method. Okay. So it just is universal format. Okay. But that's the proper name if you want to call it that way. Okay. So in order to do this, what we want to do is first change everything into a matrix. Okay. And changing everything to matrix is actually pretty straightforward. Okay. So we're just going to do a couple examples so you can see how we would change a system of equations, like, for example, like this, into a matrix. Okay. So let's suppose this is our system here. So there's our system of equations. Right? And we want to solve, or we want to, solve for x and y to figure out which ones are solutions. Okay. But again, before we get there, we just want to convert it to a matrix. Okay. Now a matrix is pretty straightforward. So I just put it over here. So a matrix usually looks like this. Like that. Okay. So it's really big bars, and we're going to put numbers inside of it. Kind of like that. Okay. So that's pretty much what a matrix is in mathematics. Okay. So if we convert over here, and usually it's going to be the x, y's, and then the equal to on the very end. So all the x's go down the column, all the y's go down the column, and whatever it's equal to goes also down the column. So all the x's go here, all the y's go there. So you always want it right in that format. So it's just going to be the 3, the 5, and again, we don't put any variables, it's all numbers in this matrix. So then 4, -3, and we're going to put a line right there. And this line signifies the equal signs themselves. Okay? And then over here, we're going to put the 8 and the 10. And this is what's called a matrix in math. So no variables. They're just pure numbers. They're the coefficients in front of the variables. But again, it's always x first, then y, just like the alphabet. X first, then y. Okay? Meaning, we may have to flip these around to make them all correctly coordinated when it comes to it. And that's it. That's how we can convert everything to a matrix. Okay. So let's do another quick example. So what if it's a little jumbled up? So here's our system. Okay. So unlike the other one, right? The x's aren't aligned, the y's are not aligned, and the equal signs are not aligned. So notice it's not the same format. So before we do anything, that's what you want to do. You want to put x's, y's, and then the single number all on this side itself. Okay. So notice on the first one, we're going to have to flip a couple things around. So first, we're going to bring the y's here, and then bring this one over there. So if we could subtract the 4y on this side, and then now subtract the 8 to both sides, we now have that. So now we have x's, y's, and then equal to. And over here, all we have to do is swap these around, right? So it's going to be a minus x plus 4y equals 7. So now that we have everything aligned, now we can convert it into its matrix format. So it'll be -3, -4, -8, -1, +4, and 7. Right, so any questions? I'm just going from here to there at all. No? Everybody comfortable? Definitely want this on the test, just like you. 10 points, right? Boom, boom. I'm sure, right? When it comes to it. Okay. So now that's not too bad, right? So what I want to go now is, okay, what can we do here, right? And the cool thing is we could do everything here that we would do up here, right? For example, let's suppose we're going to do the elimination process. So remember, the elimination process means I can multiply everything by numbers, right? So I can multiply this whole thing by like -2. I can multiply this whole thing by +2, which means I can do the same thing down here. I can add these two down. So I can add these two rows together and make a whole new one. Well, the same thing applies here. So that corresponds to something called the matrix row transformation rules. So there's 3 major things we could do with matrices. The first one is I can interchange any 2 rows I want. So I could just swap places. Okay? And I'll give an example of each one in a little bit. Okay? Number 2, like I said earlier, you can either multiply or divide any element in the row by any non-zero, meaning you can multiply or divide by something that's not a 0. So like -5, -1/3, anything like that when it comes to it. Okay? And the last one is the most interesting one of all, is you can replace a row of a matrix by adding that row with another row. And that's the one that catches a lot of people when it comes to it, you know, how that goes about, but we'll talk about that a little bit more, okay? So I'm going to give you guys an example of each individual case what we have here, okay? So let's suppose we have this matrix. Okay. So number 1 says I can interchange any 2 rows, meaning I can swap these rows out. So remember, this is a row, right? Rows go this way, right? Columns go this way, if you want to, right? So I can swap these 2 rows to go make it look like this now. So it'll be 4, 8, 7, -1, 3, and 4. So that's what number 1 says. I can swap them around. But again, I can't swap a number. I have to swap the entire row, not just a single number, right? So if you want this one over here, that means everything right here now goes up there, and everything here must go at the bottom. Okay. Number 2, I can multiply or divide the entire thing by a number. So again, let's suppose we have this as our matrix. Okay. And now let's say I want to multiply the first row. So this is the first row, right? By 3. And I can do that. And let's say I also want to multiply the bottom row, the second row, by -1, I don't know, half, for instance. And you can do that. So you can multiply everything on the top by 3. So that's going to be -15, 3, and 9. And now do the same thing, but now multiply by -1/2. So it'll be -3/2, -1, and now +3/2. So you can either multiply or divide by anything you want. But again, it's not just a single term, it's you have to distribute to all of it itself completely. All right, so before we go any further, any questions on what we can do for steps 1, rule 1 and rule 2 based on matrices at all? Everybody comfortable there? Okay. So now let's go to the difficult one, because we're going to be using this one a lot, this entire section. Okay. All right. Replacing a row. Okay. So let's suppose we have this happening. It's not a negative, it's just not there. Okay. All right. So when it comes to replacing a row by adding the row with each other, okay. Let's suppose I'm going to add row 1 plus row 2. So I'm going to add this whole thing to that whole thing, and I'm going to replace row 2 with the answer. Okay. Now this is what's happening. So I'm going to be adding them. However, the result I get is only be in row 2, meaning row 1 stays the same. So now if I add straight down, right? So 3 plus 3 is 6. Negative 8 plus 8 is 0. And then 4 plus 5 is 9. That's what I mean by when you add, you can subtract, you can replace a row completely with that result. Okay? But the thing is, you can only replace one row at a time. That's the reason why row 1 had to stay the same, because I can only change one whole row at one single time. I can't do it twice. So I can do it again, but I can only do it in one single step there. Okay, so any questions on what we just did?
I have a question about the second one, like the second row that you did. Did you choose 3 and -1/2 just like random, or?
Yep, I could choose whatever. I just chose them at 3 randoms. Yeah.
Okay. Okay. Thank you.
We'll get to it when you want to choose an exact number, but I just chose it just so you guys can see. You can multiply just one whole thing, or mix and match when it comes to
Okay, I just want to see how you got the numbers. Okay, thank you.
No, these were just randomly picked.
Okay. Okay, thank you.
So why don't we do a little bit more practice with this third step, because the third step is going to be pretty much what we're going to be doing this entire section. And again, it's the most difficult to do because, what I mean by replacing and keeping everything the same, okay? So we're going to do some more practice. So let's suppose we have this matrix here. So this is a 5, sorry. Anyway, so off 5. All right, so what I want you guys to do, or what we're going to be doing right now, is we're going to be adding row 1 plus row 2, all right? So like we did right here. And now we're going to replace row 1. Okay. So that's what we're going to be doing. So therefore, if we're replacing row 1, which one of these row 1 or row 2 is going to be the same?
Row 2?
Yep, so row 2 is not changing, right? So before I do any calculation, any math, I'm going to copy what's not being changed. Does that make sense for everybody? Okay, so now I do the results, and you always just straight down, right? So -5 plus 2 is -3. 10 plus 3 is 13. 14 plus 9 is 23. So notice, right, I replaced row 1. That's the result. I plug it in. Okay. And I can do this over and over and over again. So I can keep going and say, now I'm going to do, I'm going to do 2 times row 1, and then I'm going to add it to row 2. And the result, so I'm going to replace the result in, let's say, row 2. So now I could do a combination of this one and this one together. Okay, so how this is going to go about. But again, same thing. I'm replacing row 2, so therefore this is going to be the same. Right? Okay, first step. I'm going to multiply row 1 by 2, right? Order operations. So first things first, multiply everything by positive 2. That's going to be negative 6. This will be 26, and this is going to be 46. And then after that, I'm going to add it to row 2. So again, just add straight down. Negative 6 plus 2 is negative 4. 26 plus 3 is 29. And then 46 plus 9 is 55. So again, everybody comfortable what we just did? It's pretty good. Pretty good going from here to here, what we just did to there. Okay, let's just do one more operation then. All right, so let's now multiply negative 2 by, or sorry, positive 2 by row 1, and then subtract row 2, and then we're going to replace row 2. Okay, so lots of stuff to do. Okay, now again, before we do anything, we're replacing the second row, so therefore the first row is still going to be the same. Everybody agree? So before I do any math, I know right off the bat, I'm just going to write this stuff down. Okay, so now why don't you guys try doing the next one? What are the 3 numbers there we're going to get? Go for it. Give you guys another 30 seconds. Try it out. Okay, looks like everybody was able to go. Okay, so yep, so you guys got to be careful, right? So first we're multiplying everything by positive 2. So it's going to be negative 6, 26, and then 46. And now be careful, I'm subtracting. So -6 minus a -4. So be careful, right? This is -6 minus a -4. So it ends up being, you're adding the 4 together. So it's going to be -2. So 26 minus 29 is -3. And then lastly, 46 minus 55. And I think that's -9. So I think everybody, we did the error. Yeah, good job. So you guys caught your error before. Good. So again, any questions of what we just did? Getting those numbers. Is everybody good? All right. So the only thing we haven't done is, remember, just like here, I could do 1 and the other. So I can multiply this by 2. I can multiply this by 3, but it's the same process, right? You multiply and then do whatever operation it's asked you to do, okay? And in most cases, we're always going to be adding. So, don't sweat too much about it. But usually I just give you guys a loop to see if you guys are understanding this process, okay? Okay, so this whole thing is called row reduction method, how to solve for a system of equations. Now, you're asking, well, how do I, do this kind of method to solve for a system of equations? Well, the whole goal is to make at the end looking like that. So somehow we're going to be using all of this information, and at the end, we're going to make it look like this, where this is some number and that's some number there. Okay. Now the cool thing is this translates to x equaling whatever that number is, and this translates to y equaling whatever that number is there. So that's how we're going to solve for a system using row reduction format. So our whole goal using this process is somehow get this number here to be a 1, this number to be a 0, this number to be a 0, and then this number to be a 1. And then everything else falls in line pretty nicely. Now, you may think, okay, that's a lot of information, but we're just going to be repeating over and over and over until we get our end result here when it comes to it. Okay. So let's actually try one so you can see how it goes about doing it. Okay. So again, remember, just think what we just did here. We're just going to repeat over and over again. Okay. All right, so let's just try an example so we can see how it would work out. Okay. So we want to solve for this system, right? So that means the first thing we have to do is convert it to a matrix, right? So that was the first step. Oh. There we go. Okay. Now, how do you start? Where do we start, right, is the question. So what I always like to do is, using this process, is I always like to get this number to be 0 first. And that's going to be my goal, to make that number to be a 0. Okay. And everything else will be nicely fall into play. But I want to start somewhere, right? And usually the best way is to start here. Never want to make this a 0 because, that's going to be fractions. Oh, that's going to be horrible, right? If I'm trying to make that a 1. So I want to make this to be a 0. Okay. So therefore, at the end, if I would add these two up, right, and replace it, just like we did here, the end result will be a 0 at that spot. So best thing is, first of all, I got to make these two numbers first the same, right, and opposite sign. So kind of like the elimination method, right? Make them the same number and opposite sign. So what's the only number they can get them both being the same number? What do you guys think? What was that?
15.
15, yeah. So 15 is the only thing, right? Well, it's the smallest of them, right, when it comes to it. So that's what we're going to do. So I'm going to figure out how to get 15 here and figure out how to get 15 there. So let's do that. So in order to get 15 here, I have to multiply this one by 5, right? So I'm going to multiply row 1 by 5. And in order to get 15 here, I'm going to multiply by row 2 by row 2 by 3. Okay. Now remember, I just don't want the same number, but they have to be opposite sign. So I'm just going to tweak it. I'm just going to say I'm going to multiply the first one by -5. Make it easier. Okay. So let's do that. So we're going to get this now. So multiply. So the first row by -5. So that's going to be -15. That's going to be +20. That's going to be -5. And on the bottom, multiply everything by 3. So that's going to be 15. That's going to give you 6. And that's going to give you, don't know, is it 57, I think it is? Let me check. Yeah, 57. So again, everybody comfortable with what we just did? Okay. So remember, my whole goal is to make this a 0. So therefore, I'm going to now add row 1 plus row 2. And I'll leave it up to you guys. Am I replacing the first one or the second one now?
Second one.
Everybody agree? Because I want this to be 0. That means I'm not replacing anything. So it's going to copy that out. So the result will be replace row 2. So leave row 1 all itself. And then result will be now copied in row 2. So I'm going to have 15 minus 15, which is 0, which is what I wanted. 20 plus 6 is 26. And then lastly, -5 plus 57 gives you 52. 52. All right, so far so good for everybody. So got our goal, right? We got the 0 right there. Okay. All right. Now the next goal we want to figure out is to get this number to also be 0. So we the whole goal is just to make those 2 zeros and everything else goes kind of nicely. Okay. So we're actually halfway there. We got one of the zeros. Now we got to figure out this one to be a 0. But guess what? We're going to do the same process we just did here. So it's kind of like rinse and repeat, you know, starting from scratch when it comes to it. All right, so same situation. In order to make these 0, these two have to be the same number, but again, opposite sign. Okay. And so it's going to be pretty big numbers here. So I think we're just multiplying both the same would get it. So say we're going to multiply row 1 by 26 and row 2 by -20. So first row by +26. So these numbers are going to be pretty big. And this is still fat 0. So notice we just did this step here, right? So basically we're just copy and pasting now. So now at this step, so now next step is you just add accordingly. So we're going to add row 1 plus row 2. And remember, we want to change this to be, so we're changing this number, so we're going to replace row 1 now. And let's see what our end result is going to be. So adding straight down, so that's still negative 390. This is 0. And adding this down gives you negative 1340, I think it is. No, this should be a 7, I believe. Yeah. Rewrite it. And there we go. Believe it or not, we're actually done. Well, we just one step, but it's actually not that bad. Okay. So that's our goal. We got 0 zeros. So therefore, the last step is to make this a 1 and that a 1. So here's a fun fact, right? What number do I need to multiply to this to get 1? What do you guys think?
Negative 1 over 390.
Yep. So I'm literally just going to multiply by negative 1 over 390 to row 1. And same thing in the bottom. Well, how do you make this a 1? Just going to divide by the exact same number. Because if when you divide by 0, it just goes away. So right, still 0. So first row divided by just gives you positive 1. And so 1370 divided by 390. Oh, did I mess up? Oh, it's 1, 1. I messed up. That's a 1 there. So 1, 1. 390. There you go. That gives you 3. And on this side, that should give you 2, I believe. So therefore, solving for this system, we know x is going to be 3 and y is going to be 2. And there we go. So this is row reduction format when it comes to it. Now I know what you're thinking. That's a lot of work just to get there, right? When it comes to it. Now, what I'm showing you is the long way, right? When it comes to it. So obviously because we're just learning this process, right? So, oh, well, before we go any further, any questions on what we just did? No initial questions? Are you sure? Okay, we'll find out when the homework, right, when it comes to it. But so what I'm going to show you now is, you know, if you're comfortable doing this, right, the longer you do this, the more comfortable you get, the believe it or not, the shorter this actually becomes. So let's see, we did this in actually how many steps? So 1, 2, 3, 4, 5 steps, right? Total of 5 different steps to get here. Okay. Now, if you're comfortable, you can actually break this in actually half and do far less steps when it comes to it. So let me show you now how, when you get more comfortable, how fast this actually gets into play. Okay. And again, I'll start with the beginning we had here. Okay. So what I'm about to do now is I'm going to put this and this all in one step. So what we did is we did -5 times row 1, and then we're going to add it to 3 times row 2 and replace row 2. So notice I'm doing this step and this step together. And then, you know, it just gets a little faster again once you get more comfortable with it. So notice now this stays the same because I'm replacing row 2. And the end result of this, which what we just did earlier, right? This stuff here comes into play. So first I would just put the answers up here. And then down here. No, that was 57. And just add. So that gives you 0. That gives you 26. and that gives you 52. So notice that's exactly what we had here. And now I'm just going to rinse and repeat and do the same process. Now I want this to be a 0. I do the same thing. So I multiply this by 26, and I'm going to add it to this one, so 4 times row 2, and then replace row 1 to get that result. So row 2 is not being changed, right? It was not changed. And we get this stuff. So 26 times 3 is 78. And just the opposite, that gives me 78. That's 0. And this gives me 234. And now you divide just like we did here. So divide by the opposites. So divide by 1 over 78 to row 1. Divide by 1 over 26 to row 2. And you get the same answers. Okay. But again, that's when you get more comfortable with this process. And this is the reason why this is kind of preferred once you go into higher math, because it's actually much faster when it comes to, and again, this is what a computer does and spits out as is this process. Okay. So what we did here is, we did slowly but surely break it down so you get comfortable on each steps. But again, once you get more confidence with this, it actually goes pretty fast when it comes to it. So any questions on our first example here at all? Now, obviously, you don't have to do this, right? But I'm just showing you guys, how fast you can do stuff now when it comes to it. So no questions? Okay. All right. So in that case, let's try the next one. So that's all we're doing today for the first part. Practice, practice, practice using this row reduction stuff, okay? All right, so first off, let's convert this to a matrix. So 1, 2, then 5, 2, 1, then -2. Okay. All right, so remember, the whole goal is always to make these zeros. And then I always just going from bottom to top. So I always like saying, making sure I get this to be a 0 and that one. But it really doesn't matter. That's a cool thing. The order doesn't matter. Again, you get the same result either way. So lots of ways to start this off, and lots of ways when, everything else goes on the inside, it's a little different. Okay? So first, I want to make this a 0. So in order to do that, I need to multiply the top by -2, right? That's the only way to cancel those out. So I'm just going to quickly do that. So multiply everything by -2. All right, so that's good. So therefore now if I add them, they should cancel. So I'm going to add row 1 plus row 2. And I'm going to replace row 2, right? Because I want that to be 0. So I'm going to keep the first row the same. Now I just add straight down. So -2 plus 2 is 0, which is, I got my goal. -4 plus 1 is -3. And then that gives me -12. So we got half of our goal, right? We got the 0. And now you can think of it as just starting all over again. Now make this a 0, right? Literally, it's going to be the same steps we did earlier. Okay, so now we want these to be the same number. So what's the number? So what's the same? So yeah, so what's the common number these both numbers have to be here. Like here, they had to be 2, right? Here, what number is going to be? Oh, yeah, got 12. Good, I got you. So 12. So in this way, I'm going to multiply this by 3 and this by 4. But however, right, one of them has to be negative because they're both the same sign. So what I'm going to do is I'm going to multiply the first one by -4 and the second one just by +3. Now, the cool thing, you could do the opposite. You could put a -3 and a +4. You will get the same answer, right? There's multiple ways to do this. That's the best part. So it just has to be, you know, the template I gave you has to deal with it when it comes to it, okay? So if we do that, that's going to be +8 now. This is going to be +16, and that's going to be +40. Right? Did I multiply that right? Yep. Okay. Over here, it's still going to be 0. This is going to be negative. Oh no, I messed up. This is supposed to be by 3. This is by 4. Let me start over again. This is 3. -3, 6. 12 and 30. There we go. 0, -12, -48. There you go. And now we're going to be adding row 1 plus row 2, and we're going to replace row 1, right? Because I want this to be a 0. So therefore, row 2 stays the same. And the result is going to be put here, right? So 0 plus 6 is just 6. 12 minus 12 is 0. 30 minus 48 is -18. And now at this point, we're right here, right? So last step is divide top by 1/6 and bottom by -1/12. So that gives me 1, 0. -18 divided by 6 is -3. This gives me 0, 1. And then -48 divided by -12 gives me 4, +4. So therefore, x must equal -3 and y must equal 4. And there we go. Questions here at all? No questions? For some reason, I think you guys are scared to ask. Okay, let's just try another one. Hopefully, you get a little bit more comfortable with them as well. So let's try the last one on the page here. Okay. So first off, convert this to matrices. All right. Next up, we want that to be at 0. So first things first, we got to multiply to make them the same number. So it looks like 6, right? 6 is the only way. So multiply the top by -3 and the bottom by 2. So multiply this by -3 gives you -6, +15, and -30. Multiply the bottom by 2 gives you 6, 2, and 30. All right, so now we're going to be adding both of them together, and I'm going to replace row 2, right? Because remember, I'm looking for, get rid of that one. So before I do anything, row 1 is going to stay the same. And then the result I'm going to put here. So that gives you 0, which is what I'm looking for. That gives you 17, and this gives you 0. Okay. So far, so good. Okay. All right. So next step, we want that to be a 0. Okay. All right. So therefore, I'm going to multiply the top, let's say, by negative 17, and the bottom by 15. All right. See what we get. Get 102. Negative 255. And then 500. And in the bottom, we get 0, 255, and 0 again. Okay. Next, we're going to add row 1 plus row 2. And we're going to replace row 1. So that means row 2 stays the same. Adding straight down gives you 102. That gives me 0, and this is 510. All right, and the last step, we divide by 102 to row 1, and 1 over 55, 255 to row 2. So see what we get. So we know that's going to be 1, 0. And just dividing that by should give you, I think, 5 is the answer. This gives you 0, 1, and it doesn't matter, right? That's going to be 0. So therefore, x is going to be 5, and y is going to be 0. There we go. Any questions on this example at all? No? Everybody comfortable? Are you guys sure? All right. So let's do this one. Right. We should try a couple more because I'm not fully convinced you guys are all comfortable with this. When it comes to, even in class, everybody's like, what in the world's happening? So we'll just do some practice problems. Just, if not, just humor me, right? When it comes to it. And this one's actually a lot easier. So, phew, great. The easy ones are the last ones. Okay. All right. So I want this to be a 0, which is the best part because pretty much I only have to multiply something, right? I have to make it negative. So I'll just multiply by row 1 times 1. Because all I need is a negative number, right? Comes to it. So if I do that now, I have -2, +3, and -10. I didn't do anything to row 2, so I'll just copy that down. All right, now we're just going to add both of them and replace row 2. So row 1 is going to stay the same. So the result is going to be 0, 5, and -5. And now we're just back to square one, right? Now we make this a 0. So I'll multiply by -5 to row 1 and 3 to row 2. So multiply this by -5 gives me +10, -15, and +50. Multiplying this by +3 gives me 0, 15, and -15. Yeah. Okay, so now we're going to again add the results and replace row 1. So row 2 stays the same. So that gives you 10, that gives you 0, and that gives you, I think, 35. Yeah, 35, right? Am I off there? I think so. Right? And now, the last step, divide by 1/10 to row 1, and 1/15 to row 2. So we're going to have 1, 0, and 35/10, 0, 1, and -1. So therefore, we have our first fraction. So x is 35/10, and y equals -1. And you can simplify this if you want, or you can just leave it like that. So you can have fractions. So the dreaded fractions, right? But don't worry, right? You do them at the end, which is the best part. You deal with at the end. Any questions here?
Is it okay if we put our answer in decimal form? Like, would you accept that?
Oh yeah, you can put 3.